I think it was probably in the range of about 10 impacts.
So 10 over the course of a few thousand years?
Yes, although they were probably concentrated. I think that you had a concentrated series of impacts right around the beginning of the Younger Dryas, because that's where the proxies are found. We still don't have an explanation for the end of the Younger Dryas. Something interesting, though, it's one of these coincidences that I should bring up. We talked a little bit at one point, maybe the first meeting we had, we talked about Plato and the story of Atlantis. And I noticed some of the negative comments were like, oh, I heard him mention Atlantis, so I just immediately turned it off because that's BS, you know. Well, whether Atlantis really existed or not, that's a whole nother interesting question. And as a matter of fact, I just a few weeks ago did a part 1 of a 6-part series, a live stream, where I'm like line by line dissecting what Plato actually said, going through 4 or 5 different translations, going back to some of the original Greek language that he used. But the thing that really initially, I wasn't that interested in the Atlantis thing until I realized that if you go into his dialogue, Timaeus, just before he begins the story of Atlantis, he prefaces it with by referencing the myth of Phaeton, and Phaeton being the son of Helios, who tried to drive his father's chariot in the path of the sun and completely failed, and the chariot deviated off the path of the sun, and it declined or deviated down to the earth, and it set the world on fire. Now, in the story of Atlantis, Solon is hearing this story from these elderly Egyptian priests who say that they have preserved that story in their sacred registers for 9,000 years. Is that possible? I don't know. Maybe, maybe not. But this is what was related, that it was preserved in their sacred registers and in their temples for 9,000 years. And this was prior to Solon's 10-year sojourn in Egypt, right? Solon's sojourn in Egypt happens at 600 BC. Let me think of that. Let me think of this. Yes. So basically, if you add that to the 9,000, you go back from now to 600 BC. That's 2,600 years.
Yeah.
Add that to 9,000, what do you get? 11,600.
You get around the time of the Younger Dryas impact.
The end of the Younger Dryas, meltwater pulse 1b. So you have a rapid rise, what John Shaw, Canadian geologist, the late John Shaw, called a CRE, which is catastrophic rise event. So there was a catastrophic rise event at 11,600 years ago. Plato gives that date based on the chronology from Solon down through Drapidas, through Critias the Elder, through Critias the Younger, then finally to Socrates and Plato. Coincidence? Perhaps that's what the skeptic would say. It's just a coincidence. I'm not quite so ready to dismiss things like that as coincidence, because it's pretty amazing that he puts the demise of Atlantis, that it subsides beneath the ocean as a result of an earthquake and a rapid rise of sea level, and there's meltwater pulse 1b right there. Who knows? But what to me even makes it more interesting is because he prefaces the whole story with this Phaeton myth. And then he says, let's see, I bet you I have it right here. Let's see. There we go. Let's see if we can open this up and you can see exactly what Plato says. And let's see here if we zoom down to...
Have you seen that geological formation in, I believe it's Africa?
The recap structure. Yes.
Yeah.
Yes.
What are your thoughts on that?
That it's natural.
You think it's natural?
I think it's natural. I think it's very interesting. I first discovered that maybe 20 years ago because it was when it was first discovered because of NASA photography. They were looking at it and thinking this might be a multi-ringed impact structure. So I thought, add this to the ever-growing list of impact structures. However, subsequent research showed that it was pretty much natural. And I think, yeah, here we go right here. So this is, since you brought it up and asked about it, you can see here there's a magma body beneath the structure. It's volcanic. And let's see. An external basaltic ring dike is displaced by a north-northeast, south-southwest fault system in the northeastern part of the structure and is cross-cut by carbonatite dikes. So you can see there's this whole magma chamber beneath the thing.
I see. And how do they find that?
Oh, geophysical surveys.
And so what that would indicate was that this is probably the remnants of a volcanic eruption? Like some sort of a caldera, like the same way that we have Yellowstone when they found that from space?
It was probably pressure from below causing an updoming, right? Now, you've got multiple layers like this. Now you've got a circular updoming. Now you truncate that. If you can picture that you've got these multiple stratigraphic layers, right? It forces it into a circular, sort of a dome-shaped uplift, and then you truncate it, you slice the top of that off. What you're going to have is multiple rings that are now exposed. Okay. So it makes sense if it's in that area where this volcanic activity takes place, and that this is a natural possibility. Yeah. Now, I know that Jimmy has looked at that. Yeah. And I don't know Jimmy personally. I like the guy without knowing him. You interviewed him, right? Yeah, very nice guy. Yeah, that's what I thought. Yeah. I'd like to get him out in the field with me and show him some stuff firsthand. I bet he would love that. I think he's a giant fan of your work. I like to hear that. Well, I'm a fan of his work, but I don't happen to agree on this one. Well, I mean, I don't even know if he agrees. I think he's just speculating. Yeah. He's not dogmatic. Like, he doesn't have like a rigid perspective on this. Yeah, here you can see, there's the recat structure. What is interesting, though, is look at this. You've got this structure up here, the tenoma. I forget how you pronounce that. I knew how to pronounce it, but anyways, that's an impact crater there. There's one here. We can actually, if we go back, the Tenuma crater in Mauritania, that's impact, and the Temimichat. That's it. So what's interesting though, check this out. There's one, there's two, and here's the recat structure. They fall in a perfect alignment. Now, what's the explanation there? I don't know. Could just be coincidence, right? Could be coincidence, yeah. Could be coincidence. One of the things that he said about the recat structure was that around it, the white appears to be salt. Which could be. And I mean, see, the rim rock of this is late Cretaceous, about 90 million years old. So at that point, it was below the ocean. Right? So it's been uplifted. I think this thing is about 1,400 or 1,500 feet above sea level, if memory serves me correct. So it's been eroded. You see, this whole thing here is like an erosion. You had a massive amount of water that came down over this, and most likely is what exposed this thing to the surface. It was probably buried. Let's see here. So right there is, from Plato, that's the ringed city of Atlantis to scale. The concentric rings. The concentric ring. So this is the actual scale superimposed onto the recat structure. So it's much smaller in scale. Yeah. But Plato's scale was based on what? The stade. It was based on the stade, which is roughly 607 feet. It's where we get the word stadium from. Oh, wow. Yeah, because that was the length of a stadium in ancient Greece. So when you look at Plato's version of this, sorry to take you on this detour, but I was just curious. When you look at Plato's version of Atlantis, is there an area of the world that seems likely? Yeah? Yeah. You better watch my 6-hour presentation, Okay, Joe. I will. Yeah, no, but I look, it's detailed. That's why even in 6 hours, I can't really spell it. In my podcast I did, the first 9 episodes, 2 hours each, were devoted to, I thought, well, let's kick it off with Atlantis. 18 hours of Atlantis. 18 hours of it. The last episode 9 was devoted to the recat structure.
Wow.
So I had eight hours, so 16 hours, but we had some chatter and things like that in there, so maybe more like 12 or 14 hours. So, you know who Johanna James is?
No.
She is a British actress who started doing this She's a really cool lady. She's very interested in all this kind of stuff. Very smart, extraordinarily beautiful. And she went on and did she does these like 20-minute, 30-minute little vignettes of things that she's really interested in, having to do a lot with, ancient cultures, all the kind of things that, Graham Hancock is, she reads Graham Hancock. She became a fan of mine, and she devoted one of her little 20 or 30-minute segments to, she said, I watched all 10 hours or 12 hours of Randall Carlson's programs on Atlantis. And so she did this like 30-minute little synopsis of it. Really did a great job. So we reached out to her. I invited her on. She came on. We did a live stream a couple of weeks ago with her as a guest. And just really fun lady. She's also does comedy.
Really?
Yeah. And she's very intelligent, very gorgeous. What can I say? And smart and interested in all this kind of stuff. So, there we go. Anyways, so she was very interested in the whole Atlantis thing. And so because of that, there was a lot of feedback and people wanting to know more. And so I thought, okay, now the 10 or 12 hours I did, what I'm going to do is I'm going to try to condense that down. So a couple of weeks ago, we did the first 3-hour live stream where I basically started breaking down Plato's account line by line. What did he actually say? Let's look at the geology. Let's look at the geography, the oceanography, the astronomy, and see if it lines up, if it matches up. And so I think there's one place that pretty much is not all the details, but when you look at all of the areas around the planet that have been proposed for Atlantis, I think there's one place that fits the majority of his details, and that's the Sunken Azores Plateau. And I say sunken because we know it's sunken, and it's right along the mid-Atlantic ridge. In fact, since we're on this subject, and I wasn't even thinking we'd get on this subject, there's the Azores Plateau right there. It straddles a triple plate junction, which you have the European plate, the African plate, and the North American plate here.
Well, it's up near Nova Scotia?
Yeah, it's far north. It is. But notice over here, it's really almost at the same latitude as Spain. See? And I would say that if there's any place on the planet that is most consistent with Plato's account, that's it right there.
And why is that? Without doing an 18-hour presentation.
Oh, come on, Joe. Can't we have pizza brought in?
We can.
Nah, that's why, in a nutshell, God, where do I even begin? So, I was afraid you were going to ask that, but we can look very quickly, I guess, like give you the 5-minute version, which is that there is evidence that there was a massive subsidence along the mid-Atlantic ridge. We actually talked about this a little bit, and I think in our very first discussion we had, which was what, 7-8 years ago?
At least.
Yeah.
Yeah.
Yeah. So we talked about this a little bit. Geophysics shows that there's horizontal movement, lateral movement of the Earth's crust because of continental drift, but there's also vertical movement. And that is the result of isostatic compensation. That's called, isostasy is the vertical movement of the Earth's crust. I can show you, I should have a slide right here that will help to really illustrate what it is. Let me back up to, let's see. Should be right in here. Here we go. Okay, so now this is the shore of Hudson Bay. Now this is where the ice sheet was the thickest, right? Now what are you seeing there? Hudson Bay is up here. These are shorelines because when the ice was removed, the land started rising back. So here's sea level, land is rising back.
And the land is rising because of a lack of weight of the ice?
Yes, right. So you're sitting on a soft cushiony chair right now, right? Are you?
Yep.
Okay, so your ass is causing isostatic depression of that cushion on your chair.
Right.
And if you sit up, you'll have isostatic compensation. Right?
So that's what that is along many, many, many lines.
Yes, those are all shorelines. Wow. Here's another view of it.
Wow.
Here's another view.
Wow.
That's the land rebounding a couple of thousand feet after the ice was removed. Now, the ice was removed, and all of those trillions of tons of weight, where did it go? In the Atlantic Ocean. Now, you look, the thinnest crust on the Earth is the Mid-Atlantic Ridge. And if you look at it, you'll see that there are transform faults, which should show up right here. The transform faults are these vertical fault lines that are what you would say orthogonal or right angles to the ridge itself. Here you can see very clearly the triple plate junction and how the Azores Plateau. Okay, well, since the 1940s, the first expedition in 1948, there was when they started doing dredge samples from the floor of the Atlantic Ocean, which coincidentally, the name of the ship was the Atlantis. They dredge core samples, and they pull up the core samples from 2 miles down, 1 mile to 2 miles down, and they look at those core samples, and what you had was, for example, shallow water creatures living. They weren't living. They were now, they had been drowned. You had creatures like that typically lived under 100 feet of seawater, and now they're a mile and a half below, and they're on the flanks of this place right here.
So these are fossils that they're finding?
Yes.
And they're finding fossils that ordinarily you would find in some place that was very shallow.
Very shallow. Very shallow, yes.
Or relatively shallow, 100 feet.
100 feet, yes. So this is the basic idea here. This goes back to the 60s. As it says right here, the possible tectonic implications of glacial-eustatic. Now, eustatic is the rise and fall of sea level correlated with the increase and decrease of glacial ice. So if the ice is increasing, sea level is falling, and we call that eustatic sea level fall. If the ice is shrinking, melting, sea level's rising. So that's a eustatic rise. So that's the meaning of that. When you see glacial-eustatic, that means the rise and fall of the sea level as a result of glacier growth or melting. Okay? And it says here, sea level fluctuations have received only minor attention in connection with such problems as ocean floor spreading. The purpose of this report is to point out that late Pleistocene sea level data suggests that the ocean basins have responded isostatically and by a significant amount, particularly concentrated along the Mid-Atlantic Ridge. So, I've got so much here. I'm just going to grab a couple of these things here. Yeah. So they dug up these cobbles, which are, the cobbles are, so a cobble is basically a stone or anything that's lithified that's roughly between a pebble and a boulder. A boulder, when you get, I think, to 11 inches, about the size of a volleyball, now you're in the realm of boulders. A cobble is in between pebbles and boulders, like you've heard of cobblestone streets, they're fist-sized rocks, basically. So they say here, the Atlantis cruiser and great meteor seamounts rise from a broad ridge or plateau, which extends from the Mid-Atlantic Ridge, blah, blah, blah. Let's see. So about a ton of flat pteropod limestone cobbles was dredged from the summit area of one of these sunken, what they're calling the seamounts. And a seamount is like a flat-topped mountain, right? Like the top of the mountain has been sheared off, okay? So they pulled up these limestones, right? These limestone cobbles. They dated them. One of the cobbles gave an apparent radiocarbon age of 12,000 years, plus or minus 900 years. The state of lithification, how much it is turned into rock, of the limestone suggests that it may have been lithified under subaerial conditions. In other words, in the atmosphere. That's what that means. It may have been lithified under subaerial conditions, and the seamount may have been an island within the past 12,000 years.
Wow.
So, we could go through, again, hours of this kind of research, and why it's been pushed off to the side is anybody's guess. But it just doesn't fit the paradigm. But yeah, basically, Now, this doesn't prove that there was any civilization here, but we can make a very strong case that a large section of the Azores Plateau was above sea level during the late glacial maximum.
Does it coincide with Plato's account of trade and of travel and of the way?
Well, we have no way of knowing. See, now there we have to make a leap of faith, which is this. If we look right here, you'll see, you can see it very clearly, and you can see the Straits of Gibraltar here, which was anciently known as the Pillars of Heracles. And you come here to a group of islands, and then you get to the Azores Plateau. And here, these down here are those seamounts, those truncated seamounts. So really all you have to do, here's the leap of faith you have to make. You have to go, now I don't get into anything like, whatever, flying spaceships or crystal ray guns or anything like that. I just go by what Plato says. What he's describing is a maritime culture that had navigational abilities. Something along the lines of the Minoan or the Phoenician culture, maybe by an order of magnitude, right? So now, all we have to do, really, is assume this, which to me is not so pseudo-scientific that we couldn't even consider it, which is that some group in the Ice Age had enough navigational skills to sail from Europe to islands right here.
And what would be the reason why they would go there? Like, what was so exceptional, supposedly, about Atlantis?
Well, I'll show you one thing.
A hub of trade. It was supposed to be a very advanced city, right?
Well, advanced in the standpoint that, yes, it was engaged in trade. It had a broad net of cultural connections around the world. But if you look at this is, if you go right here, let's see, the position of the Gulf Stream during Quaternary glaciations. In the present-day North Atlantic Ocean, the boundary between the subtropical and subpolar gyres runs southwest to northeast from Hatteras to the Northern Sea. So we'll get down here, right? See, in contrast, during the last glacial maximum, approximately 18,000 years ago, the gyre boundary and associated currents were more zonal and located further to the south. So here's a map showing basically what you would have had. So this is the Gulf Stream, so it's bringing up the warm equatorial waters and wrapping it right around the Azores. So if you were going to try to theorize or hypothesize an ideal climate during the Ice Age, there it is right there. You see, that Gulf Stream, it's the Gulf Stream now. That's why you have warmth basically in the UK. Right.
And is there any physical evidence other than the cobblestones or anything? Yeah?
Plant remains.
Plant remains.
Dredged up plant remains, yes. Yeah. Plant remains that would have been growing, in a climate, not consistent with the Ice Age.
What about anything that would indicate human settlement?
No, not yet. Although I've heard some things, I haven't seen confirmation. I think it's going to take submersible.
Yeah.
We're just at the very beginnings of submarine archaeology.
And how deep is this area again?
Well, you see, right now, it is, the Azores are actually islands that are above sea level. And the major part of the plateau is a mile to mile and a half underwater.
So that's where all the action would be?
Most likely, yes.
And is there any sort of plan to do an excavation or some sort of an expedition where they go underwater and look at some of that stuff and try to find